Sorry guys, I got a phone call and it cut my video off. I don't know where it cut me off, but I was just saying that if it was even degree and they both ended down, they have to end with that same end behavior. They should head towards the same infinity because it's an even degree polynomial and they have the same end behavior. Okay, so you guys have to do that one when I send you the review on your Google Classroom. All right, let's look at this one. For questions 7 and 8, determine the y-intercept of each polynomial function. Well, remember, we did this with the parabola. If we couldn't find the y-intercept by looking at the graph, who did you plug in? Well, think about it. If you're a y-intercept, that means you are a point right on the y-axis. So every point on the y-axis has what x-coordinate? 0. Your sum ordered pair where x is 0 and then some y value. So a y-intercept always has an x-coordinate that is equal to 0. So if you want to find a y-intercept, plug 0 in for x. Whatever number comes out is your y-intercept. So if I want to find the y-intercept of this function without graphing it, just plug 0 in and see what you get. You're basically finding f of 0. So if I plug 0 in, I'm going to get 0 to the third power minus 7 times 0 squared plus 22 times 0 and then minus 18. You can either type that into your calculator and hit enter or think about it. 0 to the third, 0. Minus 7 times 0 squared, well 0 squared is 0 times negative 7 is 0. 22 times 0 is 0. So what's 0, excuse me, plus 0 plus 0? 0 minus 18 is negative 18. Negative 18 is your y-intercept. It'll cross over the y-axis when y is negative 18 all the way down there. All right, you're going to do number 8 as your review, okay? All right, look at it. Now they asked you in questions 9 to 11. In 9 to 11, they ask you to write a possible equation in factored form. So it should look like this, some type of equation in factored form with the parentheses for the given graph of each polynomial function. Well, think about it. If we're going to write an equation, we basically need to figure out who our x-intercepts, who our zeros were, so we can write them as factors. And we have to write them as their factors, and we have to just decide on what our leading coefficient sign should be. So let's see what we should do. So number 1, get your x-intercepts or your zeros, whatever you want to call them, right? Then you're going to write those x-intercepts as factors. All right, and then the third thing you're going to do is decide on a leading coefficient. We're just going to keep it simple and either make it positive 1 or negative 1. All right? Okay. So if we wrote, because again, they just said to write a possible one. They didn't say you had to write the exact one, just a possible equation for this polynomial function's graph. All right, well, let's get our x-intercepts. Where does it cross the x-intercepts? And when you do that, you should watch out. Watch for multiplicity, right? Watch out for a bounce or anything like that. Okay, so let's look here. It definitely crosses the x-axis right here when x is negative 2. And how does it cross? Straight through it. So that means he was an x-intercept one time. He has multiplicity 1. He's one factor. He wasn't squared. He wasn't to the third power. He was just a normal single factor. All right, then it crosses again when x is negative 1. And again, how does it cross? It crosses completely normal straight through it. So it didn't bounce, it didn't flatten out. That is a single x-intercept, right? That is a factor that is not squared, is not to the third power. All right, then it crosses the x-axis again when x is 1, like normal. So he is a normal single x-intercept or 0. And then it crosses again when x is 2. Okay, and again, it crosses like normal. So he's not squared, he's not to the third power. All right, so now we're going to take all of these x-intercepts and we're going to write them as factors. So we're going to say that the f of x, the equation of this polynomial function would have been, well, first, If you had an x-intercept at 0, we would always start with them because they would be factors of just x, but we don't have one, so we're okay. All right, so let's see. Take -2. How would -2 been written as a factor? What factor would you have set equal to 0 and solved to get x equals -2 as a 0? You would have had a factor of, do you agree, x plus 2. If you have an x-intercept at -2, that's because you had a factor of x plus 2 that you set equal to 0 and solved to get x equals -2. All right, and again, he doesn't have to be squared or raised to the third power because he's a single root. He passes through like normal. He doesn't bounce. All right, what is this next one? -1. If you have an x-intercept at -1, then you must have had a factor of who? You must have had a factor of x plus 1. If I said x plus 1 equal to 0 and solved, I would get an x-intercept at -1. And again, because he passed through like normal, he's not squared, he's not raised to the third power, he's just a single factor. All right, I have another x-intercept at 1, so then I must have had a factor of x minus 1 that I set equal to 0 and solved for. And again, he's not squared, he's not raised to the third power, it passed straight through him. All right, I have another x-intercept at x equals 2, so that means I would have had a factor of x minus 2 that I set equal to 0 and solved for. Okay, and again, he's not squared or anything because he's a single root. It passes through like normal. The only thing you have to do is come back and either add a +1 or a -1 in front. Well, guys, look at your end behavior. It's both up. If it ended both up, would this graph have had a positive leading coefficient or a negative leading coefficient? It would have had a positive leading coefficient. So you can either come back and add a +1 in front, or you can leave the +1 out. You don't have to put the +1 in front. You could literally just let it be assumed to be there. And then your function would look like this. So either one of these would be an acceptable answer as to being the equation for that polynomial functions graph. All right, I'm gonna do number 10 with you, and then I'm gonna leave number 11 for you to do. All right, so again, let's see who our zeros are. I crossed the x-axis at -3, and it went straight through. So that's a single one, right? It's not squared or anything like that. All right, then it doesn't cross the x-axis again until x is 2. But guys, how did it cross when it got to 2? It didn't cross, right? It bounced, which means he must have been an x-intercept at least 2 times. He must have repeated or had a multiplicity that was even, right? So I must have had him at least 2 times. So we're going to count him as a double root. He must have been some factor squared. All right, and then it crosses again when x is 5. All right, so let's do it. So f of x, I'll leave that off here. F of x equals, all right, well, leave a little room to add a leading coefficient, and let's start writing our factors. If we had a factor of -3, if I had a 0 at -3, then I must have had a factor of x plus 3 that I set equal to 0 and solved. And like I said, he goes straight through, so he's not squared or raised to the third power or anything. All right, my next x-intercept didn't happen until right there at 2. So if I have an x-intercept at 2, that means I must have had a factor of x minus 2. And since it bounced, he must have been squared. He must have at least been squared. He could have been to the 4th power, any even power, but we always put the littlest one possible. So we always count that as a square. All right, and then the last one, we have an x-intercept at 5. So that would have been a factor of x minus 5. And again, he's not squared or raised to the 3rd power because it passes straight through him. And then fill in your leading coefficient. If both ends were up, then the leading coefficient had to have been positive. So you can add a +1 in front. If they were both down, then you would have had to added a -1 in front, okay? All right, so either way, you can leave it like this with the 1 in front, or you can write it without the 1. Either one is perfectly acceptable, okay? And a lot of these questions on the quiz that I'm trying to get you guys to take on that website that I sent you, it'll be multiple choice, okay? All right, I'm going to leave number 11 for you guys to do. All right. And then you have a back page of the review. I'll do this one with you, and then I might graph one and leave the other 3. All right, so number 11 says, how many real zero or zeros exist for this polynomial function? So guys, how many real zeros means how many times did your graph cross over the x-axis, right? Because if it had any imaginary zeros, they would not have crossed over the x-axis. A lot of times when you have a polynomial doing this, where it's turning and changing direction, but it doesn't actually cross over the x-axis, it's just all this turning either above or below, that means there was probably an imaginary zero, like an x value that equaled an imaginary number when you set your zeros equal to 0. That's usually what this turning means, okay? But otherwise, if they want to know how many real zeros, just count the number of times that your graph crosses the x-axis. And it crosses the x-axis 1, 2, 3 times, and they're all straight pass-throughs, which means they're all single zeros. So I have 1, 2, 3 real zeros. Okay, all right. All right, so for questions 12 to 15, sketch the graph of each polynomial function. I gave you a watch out for multiplicity. Watch out for those x-intercepts that repeat 2 times, 3 times, 4 times, whatever it is. Watch out for those double roots and those triple roots, because if you have even multiplicity, you're going to bounce. Right? If you're a double root, if you repeat 2 times, you're going to bounce. All right, I'm going to do number 12 with you, and then I'm going to leave the rest for you guys to do as your review. All right, well, if we're going to sketch his graph, I have to set him equal to 0 and find his x-intercepts. It's not factored for me, so I'm going to have to factor this. So I'm going to look for a GCF first. An x to the third and a 4x squared have an x squared in common, but I'm going to make it a negative x squared since it led with a negative. And then that'll leave me with x minus 4. Now, a lot of times we look to factor this again, but that's linear. That's degree 1. That's not going to factor again. So I'm just going to expand this as a negative x times x, right? Because it's a negative 1 times an x squared, which is x times x. And then x minus 4 equals 0. So set your factors equal to 0 and solve. I set this x equal to 0. I set this x equal to 0. And I find out that I have a double root when x equals 0. He repeats 2 times, which means he's got that even multiplicity going on. And his graph is going to bounce when we get there. All right, set x minus 4 equal to 0 and x equals 4. And those are my 1, 2, 3 x-intercepts to this degree 3 polynomial. All right, let's plot them. All right, so I have an x-intercept at 0, and I'm going to circle him because something special happens then. The graph should bounce. And then I have an x-intercept at 4, and he's completely normal. All right, what's my end behavior? Well, this is multiplied out, so I can determine it right now. It led with a negative x cubed, which means it is a degree 3, so it's odd, and the leading coefficient is negative. Well, what's the end behavior going to be for an odd degree graph? It's got to be different, right? So 1 up and 1 down. Well, which one is it if the leading coefficient is negative? If the leading coefficient is negative, it should be up on the left, the negative side of the graph, and down on the right. So let's mark that. We should be up on the left, to the left of my last x-intercept, and I should be down to the right of my last x-intercept. And that's the end behavior for an odd degree graph with a negative leading coefficient. All right, now the graph should fill itself in. Just watch out for any bounces. All right, so I have to start up. So let me start up, head towards my first x-intercept. But guys, what does it do? Because that's a double, it's going to bounce and go right back in the direction from which it came. But then what's my graph going to have to do to head towards the next x-intercept? It's going to have to turn, and then it's a normal one, so it's going to pass right through and stay down. And that's what his graph should look like. Okay? All right, I'm going to leave 13, 14, and 15 for you guys to do as part of your review. And then I'll be sending answers to the review, and you guys can send me questions, and we should be ready to take our first quiz. All right, good luck, guys.